So my first question to anybody is, have you heard of developer productivity engineering? And if you haven't, that's cool because hopefully, in the next 20 minutes here, I'll change that answer. All right. So Jim gave me a quick intro, but I'll introduce myself. So I'm Brian Demers. As Jim mentioned, I'm a developer advocate at Gradle. So I've spent a lot of my career kind of in and around open source communities, specifically in the areas of application security and build tools, right? And most people are kind of confused at how those two things are related at all. But as soon as you think about how your build tools always connect to the internet or some intranet or something, they're connected, right? Those servers, those services need to have authentication or some sort of security involved, right? So that's how I got started in both of those worlds, building kind of security mechanisms for build tools and the servers that those tools use. So as I've hinted, I've kind of spent my whole career in the Java world. I think I spent kind of a year doing some Python stuff, but then I came crawling back to the Java world. Everything I'm talking about, there's nothing specific to Java. My worldview is kind of tinged with Java, obviously, but nothing specific. So it should be relevant to anyone not in those communities. Outside of all of this, I live in New Hampshire. I have some bees in my backyard. It's been warm for the past few days, so I'm a beekeeper. I have 3 hives right now, and there'll be probably a couple more in a few months. So it'll be a busy springtime for me. And outside of all of that, I like to play a lot of board games. So if anyone here has a board game for me to try out, let me know. My family really likes worker placement games and kind of engine builder type abstract games. So if you have something for me, let me know and I'll check it out. All right, but let's get moving here. I like to start out with kind of something fun. It's you may think it's not fun. You may hate me for this question to spark the holy war of tabs versus spaces. But in the chat, we need to make sure this thing's working. So let me know if you like tabs or spaces. And while you're typing, I'll tell you right away, I'm a big fan of spaces, right? I don't know why, it's not really rational, but that's my choice. And if anyone has not seen this episode of Silicon Valley, you need to go find it. At least watch this clip. If you type tabs versus spaces or something in Silicon Valley and YouTube, I'm sure that clip will come up, but wait like an hour. So anyway, I think the spaces are winning out. So that sounds good to me. All right, so the next one, dogs and cats, right? I'm allergic to cats. So I guess technically some of you can like both of these things. I'm allergic to cats, so dogs are obviously my choice. This is my dog Zemo. He's 2. He's like 105 pounds, like almost 50 kilos, I think, if I'm doing the math correctly. Anyway, he's a big dog, and that is just some random cat picture I found on the internet. So let me know, dogs versus cats, right? Now, if you're in the Java world, hopefully you saw where this is going, right? So Gradle build tool versus Maven. If you have a favorite, let me know. There are folks that like them both. But while you're thinking about your answer, if you were paying attention to my bio slide, you notice that Maven is prominently featured, but I work for the company Gradle, right? So that's kind of confusing potentially. So maybe this is a Pepsi/PepsiCo type analogy, but Gradle, the company who writes my paycheck, created Gradle build tool, and that's what most people think about when they hear the term Gradle. We also have another project called Develocity, which is what I focus on. And that's all about making your builds faster for Gradle build tool, Maven, Bazel, and SBT. Anyway, it's a long way of saying we don't care which build tool you're using as long as you're productive. Now, this talk is not about Gradle, but there's this elephant in the room if you're in the Java world that I wanted to point out. All right, so let's really get into this conversation. All right. So personally, I hate the term 10x developer, 10x engineer, 10x whatever. Okay. I think this is a myth. So just like these creatures, right? But just like these creatures, there's a kernel of truth to all of them, right? So the best I could figure out was the origins of a unicorn was likely someone saw a rhinoceros and thought that was a horse. I don't know. Um, the centaur was likely non-horseback riding culture saw somebody riding a horse for the first time. El Cupachabre was probably based on the 1995 movie Species. And if that one's true, that worries me because I remember when that movie came out. So it makes me feel really old. Um, Yeti slash Bigfoot, though, I could not find the origin story of Bigfoot. So if you know what it is, let me know. Otherwise, maybe we're just going to say that one is not a myth. But I'll leave that one for you to debate. But anyway, just like those, the 10x developer kind of has its origin story in the study from the 80s. So you can scan the QR code and see the snippet of this study, the coding war games. But at my last slide, I'll have a QR code that will have a link to my blog, and we'll have all of these links in there. And I'll stick it in the chat. And right now there's a recording of this talk that I've given before, but I'll change it after Jim updates uploads the current video. All right, so this study, the Coding War Games, was originally created in 1977 by Tom DeMarco and Timothy Lister. They ran it later in the 80s, which I'll get to. But their purpose was to discover the best and worst traits of developers. Right. So again, you can scan that, and it's a short brief. There's a lot of data that came out of this study that I think is still relevant today. Right. So what they did is they picked two developers from a bunch of different companies and had all of the developers kind of compete against each other. Now, these two developers were kind of a pair, but they were not like pair programming. This was kind of pre that. They were just used so they could correlate some data, right? So between 1984 and 1986, there was about 600 developers from about 100 different companies that took part in this study. So they're all given the same project, so the same kind of medium-sized project, and they had to go design it, implement it, and then test it, right? And they can use any language they wanted to, and they use their own workspaces, their own computers, the languages and tools they were most familiar with, but the results were kind of surprising. And if anyone's ever read this book, Peopleware, it's by the same authors. It's based on the data from that study as well. There's an audiobook for this that's been in my queue for longer than I care to admit. I listen to a lot of audiobooks, as you may imagine, while I'm walking my dog. But I won't get into this book. But the study had a lot of interesting information. Hey, and this is why I think it probably was the origin of this 10x developer myth. Right. So the best developers outperform the worst developers in the study by about a factor of 10. Right. But before we continue, there are some non-factors here that were important. So the language the developer chose to write their programs didn't matter. Now, as long as it wasn't assembly language. I don't know if anyone here has done any assembly language, either back in university or professionally. But if you think you are productive writing assembly language, I would love to hear your story. I probably won't believe you, but I would love to hear your story. I don't think anyone is productive writing machine code, right? Someone's going to argue with me about this, but that's cool. That'll be fun. So developers with 2 years of experience were about as productive as developers with 10. Developers with less than 6 months of experience did far worse than everybody else. So that's kind of where the bell curve just kind of falls off. The developers who finished the fastest also had the fewest bugs, which was interesting all by itself. So there was some sort of standardized acceptance suite that they ran against all the applicants so they could figure out the quality of the submissions. The top performers were only making about 10% more than the bottom performers, which is wild to me, right? So if you're doing 10 times the work of somebody and only getting paid 10% more, that's bonkers. But this is not a conversation about salaries. But I don't know. I can't stop thinking about that. All right, so let's talk about what did matter though, right? So groups from the same company performed about the same, right? So the difference between the two, remember the pair from the same companies, were about 20%, right? And when compared against this kind of 10x number, that 20% isn't I can't say it, statistically significant. My tongue's tied. It's late. It's after 5 here, so I'll make up excuses all night. I don't know. But the best organizations outperformed the worst by a factor of 11.1 times, right? So again, this is our 10x number. So basically, you're more likely to work similar to your coworker than you are somebody else. And we'll get to the reasons for this, right? But this also means that the great companies out there are attracting great talent, right? So we're kind of clustering great talent, but we're also kind of clustering not so great talent, right? So our corporate environment and culture has a lot to do with how we work and how productive we are. Oh, I think my clicker's kind of slow here, so sorry about that. I mean, I'm standing 3 inches away from my keyboard. I could just hit a key, but I talk with my hands. So we're developers. We all like data, right? So as we go through this, especially in kind of the light of the last few years going through the pandemic, most of this data is probably pretty obvious now, right? So the folks that perform the best in this study had more space, right? So about 60% more space. And that was also quiet space, right? Software development takes a lot of focused effort, right? We don't want to be interrupted all the time. So quiet space kind of goes hand in hand with private space, right? And they can mute distractions. So we could probably have a whole discussion about how bad distractions and pop-ups and notifications are for your thought process. Okay, I can't imagine doing some sort of deep technical work and then getting notified every 30 seconds. Now, those of you who are on call or take on call shifts, that's unfortunate. Like that's just the nature of the beast. But when you are able to mute your distractions, you absolutely should. Now, anybody who's ever worked in an open office space is looking at this data and either crying or laughing or maybe a little bit of both. Those people who designed those spaces did not look at this data, or they did, but they also saw some other data that really mattered to them the most, right? So anyway, all of this data, we've kind of normalized it now. So if you've worked in one of these places for a little while and it's loud, it was loud yesterday, it's gonna be loud tomorrow, it was loud last month. You just normalize it. You stop thinking about it. Now that's not good, right? So improving these situations will improve the developer experience. So 10x organizations are not they're manufactured. They're not born, right? You just don't become a 10x organization. You have to work at it. So we need to pay attention to developer experience, removing impediments, obviously those noisy environments, but focus on developer joy. Now, usually when we're in a group setting, I love to ask this question: Who has heard the term developer joy? It's kind of usually kind of a mixed bag. If you have, let me know in the comments. But the real question I like to ask is who likes to write code, right? And when I ask this in person, everybody raises their hand, right? And then the follow-up question is who likes to write code at work? And everybody's hand kind of slowly goes down, right? Unless your boss is there, then it's still up. No, I'm kidding. Like, there's some people who do like to write code at work because they work at great places and they feel supported. But it's not that we don't like to write the code at work. It's that we don't like all the frustrations that we have to deal with at work, right? Flaky builds, maybe your test take an hour to run, whatever it is. Those things get in your way and they're frustrating, or maybe it's just too many meetings. I don't know. But this is one of the types of things that DPE fixes. And I'll come back to that in a few minutes here. But let's talk about how we measure productivity in general, right? How do you measure productivity? Think about it for a minute, right? How does your team measure productivity? Do you count story points, the number of issues completed, tasks done in a week, whatever it is? Everybody's kind of has a fuzzy answer. And does that actually mean you're productive, right? Maybe, maybe not, probably not. I don't know, right? So the folks at Microsoft and the University of Victoria sat down and thought about this. And they realized that productivity can't be measured by a single metric, right? So instead, they came up with a space framework and they basically break this down into 5 categories. So as you can see on the screen here, so satisfaction and well-being, so that's your happiness, stress, purpose, those types of things. Performance, are you meeting your deadlines? Activity, writing code, that's when I want to put my blinders on and focus on. I just kind of want to write code, right? Next up, communication and collaboration, and then efficiency and flow. Okay. So part of the problem with the space framework, there isn't a single way to get this data, right? So you can either mine data from a bunch of sources, or you can send out surveys to your team, right? Ask them a bunch of questions, and then you kind of categorize those questions based on these categories, and then you see how you do. However, if you did that, if you asked, say, your developers and your managers how they would define productivity, they're going to give you 2 different answers, right? So this is interesting all by itself. There's probably merits like a deeper dive, but I only have a single slide here. So managers are typically going to define productivity in terms of performance, right? So that's meeting deadlines. And developers were mostly concerned with cranking out code. Okay, so the big problem with these things, though, is satisfaction is single digits in both of these cases, right? So that's a problem. I know personally when I'm happy about something, when I'm engaged, right, in a product that I'm working on, I'm happier. I feel like I'm working better, even if that's a subjective working better. I know that I'm communicating more with my coworkers. I'm trying to share everything I'm doing. I'm just excited about it, right? And my ability to stay focused is increased. So that's me personally. But I feel like there's probably some trends there as well. But in general, regardless of this data, we really need to be better aligned on what productivity means for us, right? So reporting dates up the food chain probably isn't helping anybody, but counting lines of code definitely isn't either. All right. So all these things we've been doing, right? DevOps, 12 factor, agile, these things are all great. But as we eliminate one bottleneck, we uncover another, right? So agile removes some of the pain of waterfall. 12 factor made it easier for us to deploy our applications. And then DevOps comes along, and now we're treating our infrastructure as code, right? So, our environments are cattle instead of pets. But what about all of the pain developers go through every day, right? So we really need to think about that. So 10x organizations need to intentionally think about these things, specifically in the areas of reducing build times, increasing feedback cycles, and basically just improving the reliabilities of your builds and your tools. So this is why I think it's time for developer productivity engineering, or DPE. Okay. So DPE is an engineering practice that uses straightforward techniques to foster developer success and happiness. Now, I've said that line like 100 times, and it's just kind of like a bunch of words at this point. But think about this: an engineering practice that focuses on developer success and happiness, right? That's a win-win, right? I want to be successful. I want to be happy. Sign me up, right? But in general, we're going to focus on 3 things: fast feedback cycles, tool chain reliability, and then actionable data, which then I can feed back into the previous 2 to make me more productive. So the developer experience is at the forefront. We're going to optimize everything we can, build tools, CI times, whatever it is, optimize your processes and your tools. Okay, so I touched on a few of these already, but I like to point out kind of every decade or so, there has been something that comes along that tries to decrease cost and increase performance, which is a good thing, right? So the 70s and 80s, there was a big focus on just-in-time manufacturing. We want to have less products sitting around, right, on shelves. We want to get the product in. We want to get the product added to some other assembly and then get it out the door or ship it to a customer. In the 90s, there was a big focus on change management, how did a process or change affect our whole organization, right? And then in the 2000s, so this is kind of where my career started, software ate the world, right? So I remember early in my career, um, there's a big focus on agile lean, right? But before that, I spent weeks and months on requirements docs. This is probably the worst time of my life, right? You just sit there and you work on a requirements doc, and then um, you know you kind of forget about it for a few months, and then you get to the end of your cycle, and then well, it's not a requirements doc, and then all hell breaks loose, right? That's a whole different story. But now we kind of iteratively do these things, right? Which is good. Then kind of after agile, we see DevOps, right? So I'm going to joke a little bit, but I think DevOps is a solved problem, right? It's a hard problem. There's a lot to do. Uh, I'm half kidding, remember, but it's we understand the space now, right? So I think the next big bottleneck is developer. Now, I'm not being negative. It's not that developers were slow, right? I think it's all the crap we've been putting up with, right? So again, slow builds, flaky tests. Maybe I have a half an hour between meetings. That's the period of time where I'm working on my code. That's not going to do it, right? But career wise, DPE is an interesting shift too. So we've seen large companies, they have dedicated DPE or productivity teams. Some of those folks have moved from like DevOpsy titles to SREs to platform engineers to productivity engineers. And those roles are not just about managing CI servers. I was on a team years ago that we managed CI servers. We did a little bit of build tool stuff too to help folks, but we're largely doing infrastructure. So now kind of this shift is removing the frustration from developers, right? We really don't want to have flaky tools, flaky builds, all those things. So we want to remove that pain. Now, put on your hat and think about your first Hello World application you wrote. Okay, so for me, I think I've told this story a bunch of times, but the best I could figure was my first Hello World was the Windows like DOS prompt, or it's probably DOS prompt, not Windows prompt, but bear with me. I think I changed the prompt text to the terminal, right? I think I said Brian is awesome. Now I thought that was the greatest thing, and I'm pretty sure I hacked up like an auto exec bat or something, and I made it loop infinitely. That's many years ago. I don't remember, but I thought it was great. My sisters who were sharing this computer, not so much, right? But the feedback I got when I was working on that was instant, right? I typed the whatever it was, the whatever prompt something. I forget what the command is now, but your hello world, like super simple. You type it in, you run it, or compile it and run it. The feedback is basically instant, right? Your brain gets a sudden hit of dopamine, and you're excited. You try something else. Maybe it failed, right? But the failure was pretty quick. You tried something else, and then it worked. Again, you get that dopamine. So fast forward to today, right? Would we expect the new generation of developers to put up the same crap of modern development, right? I wouldn't, right? I would expect these kids to go do something else, anything else, rather than sit for half an hour and download the internet, right? So we want to avoid long builds, flaky tests. Those kids wouldn't deal with it. So why should we, right? Why do we put up with it? All right, so let me tell you another story, right? I'm going to wave a magic wand, and I'm going to remove all of the meetings in your calendar, and you're still going to have a frustrating day, which is unfortunate. Okay, so this is a fake story, but hopefully everybody can relate. So you start your day, and you have a feature to work on. You think it's going to take 2 hours to fix or implement or whatever it is you're doing. Okay. So you start the day, you're kind of dig into the problem, you start hacking on the code or script or whatever it is, and your brain is happy, right? You're kind of in the zone. After a couple hours of doing this, you run through your build or whatever your kind of automated tools are. You run it through your build, and as long as your build fails pretty quick, that's not a bad thing. It's a good thing, right? We have compilers to tell us when our code isn't working. We have tests to tell us when our code isn't working. Those are great forms of feedback. But if it takes an hour to get that feedback, that's kind of dragging out, right? So it can get worse than that. Maybe I just don't have the information I need to fix the problem, or I have no idea what this build output is, right? So I'm going to spend the next hour digging through, combing through his logs, slacking my coworkers. Hey, what is this? I don't understand this. I'm going to get frustrated, and then I'm going to go to lunch. I'm going to go walk my dog, or whatever it is. Um, you're frustrated. So you come back from lunch. Maybe you have a clear head and you're able to think about the problem. Maybe somebody got back to you on Slack and you get back into it. You're kind of figuring out what it was. So you're back into the zone. You're fixing your issues you were having. And then you're about ready to submit this to your CI system or pull request or whatever you're doing. So you run a local build again before you push it. Great, that worked. So then you're waiting for the CI build, right? Nobody in your team is going to look at your pull request until the CI turns green. So you're just sitting there waiting for it, right? But then the CI system fails. You have no idea what happened because it just worked on your machine, right? Why doesn't it work on the CI machine? So you spend the next hour digging into that. You don't know if it's a flaky test or if it's a real problem that's uncovered on the CI system. Whatever it is, you spend the next hour banging your head on the keyboard. Now it's late, right? You thought this thing was going to take 2 hours to fix in the morning, but it's the end of the day. You have something to do at night. You're just trying to scramble to get this done, right? It's a bad day. Okay, so anyway, so that's kind of a fictitious story, but we all have a story like this where some task was gonna be quick, but you just one thing after another, failures or whatever it is, you didn't have enough information. We owe ourselves a better experience than this, right? So this is what DBE fixes. And we've all seen this comic, right? Everybody loves this comic. We like to make fun of this comic. We like to emulate this comic, all these things. But even if you're not sword fighting, right, you're probably, if you have an hour-long build, you're probably going to do something to fill your time, right? Hopefully it's something other than email. So again in the chat, how long are your builds, right? Are they 10 minutes? Are they 30 minutes? Are they 60 minutes? Whatever it is, give me a ballpark estimate of how long those things are. And remember, your builds of your software includes your tests. Okay. We've seen cases that are definitely up to 90% of your build time is test time. And that's not necessarily a problem, but it does mean we need to handle things a little different. We need to be aware of these things. Now, this comic, right, crossing things out, compiling, probably used to say like Stack Overflow is down, GitHub is down, and now maybe it's ChatGPT or your favorite Copilot-esque thing is down. Whatever it is, maybe you're not telling your boss you're using ChatGPT. I won't tell him either, don't worry, but you're using it. All right, so what else does DBE solve, right? So let's look at this developer on the left here. Each one of these bubbles around his head, these circles, are feedback loops, right? Your IDE does this all day long, right? So you type something in, you get a little red squiggly. That's instant feedback, right? That is the best form of feedback you can get. Sometimes your IDE gives you that little red squiggly before you're done typing. That's a whole other story, but it's instant feedback. That is great. If you run a test from your IDE, that's also great. That should be really quick. You're getting feedback really fast all day long. But sometimes those cycles take a lot longer. Like if you're running an integration test and maybe you're going to spin up, an environment before you run a test, right? Those things start getting on your nerves. They pull you away from getting in the zone. They pull you away from your code. Now you're just waiting. And sometimes there's failures in our code that would have been avoidable if we had more data, right? Or maybe a test is flaky. And I just spent the last hour working on a test that I thought was related to my code change, but it ended up being a flaky test that was in the code base for the last month. Nobody told me. I didn't know, right? More data would allow me to be more productive. So all of your developers are running into these types of problems. And again, this is what DBE tries to solve. Okay, so this is a big chart. Don't worry too much. I'm going to walk through this. It's actually pretty simple. So if we focus on just fast feedback cycles, a lot of things happen. Okay, so obviously, first off, we have less idle time, right? Which is great all around. If you have long builds, say over 20 minutes, you're going to context switch away from your build while you're waiting for that process to complete, right? Every time you do that, it's a context switch. Every time you context switch, research says it takes about 10 minutes for you to be productive again. Now, every time you context switch away from your whatever the task you're doing, remember you have to context switch back to it, right? So that's basically 20 minutes of time that you're just burning, right? Because your processes are too long, your builds are too long. Now, the problem with context switching, it actually causes cognitive fatigue or brain fatigue, right? So this there was research a couple years ago. I forget where it was out of. I think I have a link at the end that points out this. But anybody who's lived through COVID, which is hopefully everybody here, right? We all have, we've definitely all got burnt out over those few years. Zoom fatigue, whatever it was, we've all seen this firsthand. But this happens in small doses all day long. Okay. So anyway, so we're going to reduce the cognitive fatigue. We're going to reduce context switching. So we're going to be more focused, right? More focused developers should create higher quality software, right? That's a goal. That's a win all by itself. Now, the other thing, if we come back to just focusing on fast feedback cycles, that means I can have more frequent builds, right? Instead of my build takes an hour, now it only takes 2 minutes. I can run that way more often during the day and get the feedback that I need to complete my tasks. So that means I can have smaller change sets. So hopefully I can focus on doing atomic commits or just, small change sets in general are good. My PRs, my pull requests are going to be smaller. So if you send me a pull request with 10 lines of code in it versus 10,000 lines of code in it, which one am I doing first, right? I'm going to get to that 10-line pull request right away, and I'm going to avoid doing that 10,000 line pull request as long as humanly possible. Okay, so I've given this talk a few times, and I used to joke about this fictitious 10,000 line pull request, but maybe 3 months ago at this point, I got a 10,000 line pull request. It was 7,500 lines added and 2,500 removed. Okay. It was a great change. It was a big refactoring of this open source project, but my brain cannot comprehend 10,000 lines, right? It just can't. I'd scan through it. Looks good to me, right? And then we had to worry about, getting that thing merged, making sure nobody else was doing any work because it was huge. It was a pain in the butt, right? So smaller change sets, we're going to have fewer merge conflicts. When things go wrong, it's easier to debug them. And then, of course, things are going to go wrong, right? It's the nature of the beast. It's easier to fix them once they do. All right. So all of these benefits that I mentioned are just from fast feedback cycles, right? So what do we do about this? How do we speed things up, right? So I'm going to go over each one of these in a bit of detail. The first one I'm going to spend more time on, but I'll get to these in the future slides here, but I'll just go through these 4 items pretty quick. In general, if you take nothing else away, I think you should start treating your builds like you do your applications. Okay. So if your application is slow, one of the first tools we jump to is some sort of cache, right? So just like that, we can add a build cache to our builds. Predictive test selection is a beast all by itself. I'll get to that, but it's essentially avoiding doing work, right? If you can avoid doing some work, you don't need to do it. And that'll speed up your builds as well. Test distribution. So just like applications, if we have a bunch of work to do, we're going to distribute them across a bunch of nodes. We can take our tests and do the same type of thing with it, right? Distribute the work. And then last up, we're going to monitor them. So if you have applications in production and you are not monitoring them, let me know in the chat. Okay, I don't expect anyone to actually answer that question. I wouldn't. I know there's always applications that are in production that are not monitored, but we know better. So why are we treating our builds the same way, right? We want to get data out. We want to start monitoring. We want to look for trends and changes in behavior, right? All right, but let's talk about build caching for a few minutes here. And what do I mean by this, right? So folks in kind of the Java world, or even NPM or anywhere where you're downloading dependencies, you may think of a cache where we're talking about dependencies. We are not. This is two different things. So in the Java world, especially for, say, Maven folks, Gradle folks too, right? So we cache our dependencies typically on like a corporate proxy, like a Nexus or an Artifactory. So we download them from Maven Central, we put them in our corporate network, and then from there we download them to our laptop, right? The proxy just makes things faster. From there, on our laptop, they're in our home directory. Essentially, for Maven folks, it's your M2 home directory / repository. There's thousands of jar files in there. That's optimizing for network I/O, right? Build caching is different. So a build cache is going to cache individual tasks or goals that are typically CPU heavy, right? Specifically compilation and testing. Those are the big ones. So in the Java world, Gradle build tool introduced a build cache in 2017. Maven has an open source one that came out about a year and a half ago. We also have a build cache for Maven. We don't care which one you use. Our product Develocity works with all of these things, so it's a non-issue for us. But at a high level, they're all doing the same thing. So I'm going to talk about them in kind of this broad category. There's also two ways to use a build cache, both local and remote. So a local build cache, you can kind of think about it as for me, right? Those, I'm going to cache entries from my build on my laptop. They're not going anywhere else. My next build on my laptop will be faster. If I move to somebody else's laptop, my build's going to be slow again or whatever. A remote cache solves that problem. So my whole team, it can be more productive because my CI server is going to populate a remote cache. And then anytime I don't have a cache entry locally, I can just download that, and that will speed up my build. Okay, so how does this work at a high level? So you can think about a build action, right? So again, in the Java world, Gradle tasks, Maven goals, they all have a set of inputs, right? So for compilation, you have source files, you have some sort of dependencies, the compiler version itself, right? Because every time you compile something with a newer version of a compiler, that could potentially change the output. You have compiler arguments, whatever the arguments are in for the compiler. All of those things are inputs into the action. And then the outputs would be class files, right? The output, the compiled binary output. If I'm running tests, the output is a test report or maybe coverage data, right? So I have inputs and outputs. For a given set of inputs, I need to get the same set of outputs, right? I'm going to have some stability here. If the same inputs create different outputs, that's not something I want to cache. So I take those inputs and we hash them. So just hash all of the inputs, and that gives me a cache key. I associate that key with basically a zip file of everything that was created from that action, right? So again, compilation, I'm going to zip up a bunch of class files, right? I'm going to store those over in my home directory. Next time I see a build that has the exact same inputs, I'm just going to extract that zip file. I'm essentially trading a little bit of I/O or a little bit of CPU or a lot of bit of CPU for a little bit of I/O, right? So this should speed up my build. Now, ideally, if my CI system is publishing those cache entries, I could clone a brand new repository that I've never built before. I could download my dependencies and download the cache entries all automatically. And then my build might only take a few minutes or a few seconds, depending on the size of your build. So I'll get to an example here. So let's pretend I have a 4-module Maven project, right? There are some dependencies between these modules. I have a core module, that's kind of the root, that's kind of all by itself. And then export API and service depend on core, and then web app depends on service. So you can kind of see, lots of applications have a graph like this or more complicated version of a graph like this. Now, if I run a clean build here, I'm going to build everything, right? That's not a surprise to anybody. But if I make a change to the export API, right, I'm just going to have to build that leaf, which is great. So if I'm doing this on my laptop, I don't need a cache. I can just go to this directory and I can just build that module all by itself, right? I know I made that change. I know I just need to build that module. That's not true for my CI system.
Interrupt your flow.
Sure, yeah.
John Shelburne he says, dumb question. is this part of the Docker file, or if it's not, where would it be in relation to a Docker file?
Yeah, so Docker also uses a similar technique, right? So if you think about Docker, Docker uses a cache. So I didn't put it in this talk, but I have another talk with a basically Docker Docker slide. It's essentially Docker uses a build cache. So if you build a Docker container, right, the first time you build it, it's going to run it's going to execute every run line in your Docker file, right? And then if you think about if you change, say, the bottom line in your Docker file, the bottom run line, it's going to pull all of those previous run lines from your cache, and it's just going to run what's changed. Okay, so that's a build cache. Now, in the Java world, I am talking about kind of some specifics about modules and everything. It's essentially just relationships between these tools. Docker or pick your favorite build tool. They all kind of work the same way as far as kind of this relationship dependencies go. I hope that answers the question, but I do think the easiest way to think about a build cache is potentially a Docker file, right? Go find your favorite Docker file, run it, change the middle run line, run it again, and you can see it'll say, I think it says from cache, or it says something in there, and it just skips those lines. All right, so if going back to kind of the Maven example, if I'm just building my project, I know that I just need to build this one module, right? My CI system is going to build the whole thing. It has no knowledge of what I changed. So with a build cache, now my CI system can be smarter, can add, can know that it just needs to build the blue and the yellow there, and it doesn't have to build everything else. So speeding up my whole build, making my CI builds faster, making my whole team's builds much faster. Now, again, this is kind of a Java specific thing, but if I make an implementation change, if I change an implementation detail to something in my service module, right, I can avoid doing a whole bunch of compilation, a whole bunch of testing. I only need to run the compilation for my service module. The public API hasn't changed, so I don't need to recompile my tests. I don't need to do my static analysis. I do need to run my test because I did change some code. And then things that depend on service, I only need to run their tests, right? Because the implementation has changed, but the public APIs haven't. All right. So I've spent a lot of time talking about kind of build caching and specifics. The rest of this is kind of higher level, so don't worry. Stay with me. Again, I did touch on remote cache. We've often seen about 50% of cache savings comes from remote cache. So if you think about it, my team is more productive if we're sharing information, basically, right? But I'm on the East Coast. I work with folks in Europe. I work with folks in California. So by the time I start my day, my European colleagues, it basically works whatever, half their day or more. And by the time I stop my day, my California colleagues still have a few hours to go. So by the time I get in the next day, a lot of code changes have gone into our code base. Each one of those code changes is potentially a cache miss, right? So a remote cache helps with this. So every time I pull down the latest changes, my CI system is already populated, the build cache. So now my local builds will be faster. All right. So I love to talk about reproducible builds. So if anyone has not heard of reproducible builds, check it out. I think it is probably the best thing since sliced bread. I'm half kidding here. So reproducible builds, if you haven't heard about them, it's a set of practices that makes it possible to build your software multiple times and get the same output byte for byte. Okay, so this is for everything. So whatever tool change you're using, there's probably an entry on reproducible builds for that. Now, so this is usually looked at as a security mechanism, right? So you can basically validate whatever you build. So if you build some code and I build some code, right? We take the same code, you build it and I build it. We should get the same output byte for byte. and we can compare the hashes of those outputs. And then if they're the same, I know that you didn't inject anything malicious, and you know I didn't inject anything malicious, right? So now we know our builds are valid and they're more secure. It's a better security posture. So the key ingredient here is the same input creates the same output. Okay, so that's an awesome thing, because this is what the requirements are for build caching. Same input creates the same output. So now reproducible builds is a security practice that makes it possible for you to be more productive, right? Which I think is mind-boggling, because most of the time, all of our security practices do not make us more productive. We could have arguments about finding vulnerabilities, and that makes you more productive, but you know what I mean. Process generally doesn't make you more productive. All right. So predictive test selection. So this is an interesting one all by itself. This took me a long time to kind of wrap my brain around. So essentially what this means is if I make some change, I probably don't need to run my entire test suite. I probably only need to run the tests that are likely to be related to my change. But that's not what happens. Typically, we run our whole test suite for everything, which means I'm now sitting on my hands, wasting CPU cycles, wasting my time, waiting for my build. Okay. So Facebook, or now Meta, Facebook, when they created this, came up with this novel idea called predictive test selection. Okay. Again, this link will be at the end. But they had problems with kind of the conventional approach. So the conventional approach is kind of a dependency graph based, right? So if I make the red changes, the diamonds across the bottom, I'm going to figure out everything that code touches, and I'm going to run all of those tests that come into play here. Now, this is great. This works, but it means I'm going to run a whole bunch of tests that I probably didn't need to. So what this paper describes is the machine learning model that takes into account a whole bunch of things, right? So file names, extensions, the amount of times, the frequency a code file changes, a whole bunch of things, feeds them into a model, and then predicts how likely a test is to pass. If the test is likely to pass, I don't need to run it, right? Now, when I first heard this scared me to no end. This seems freaky. Why would I not want to run my tests? Well, there's a lot of cases where this works really well. It does not work in all cases. We have our tests for a reason. We still need to run the test, but this means my local builds on my laptop can be much faster because I don't need to run as many tests. If I'm doing pull request pre-merge builds, so that is, I submit a pull request and that kicks off a build, I can run PTS against that build and minimize the amount of tests I need to run and speed up that kind of pre-review process, right? Once things get merged after my pull request, I want to run all my tests, or at least the rest of the tests that I didn't run. So that way I still get some performance, but I also get the assurance that all my tests ran and passed. Okay, so next up, I mentioned test distribution. So just like our applications, right, we want to just distribute work across a bunch of nodes. So I mentioned this before, but we've often seen 90% of builds are test cycles, right? So this is where test distribution comes in. So we want to take that 90% of your time and we want to distribute it, run it in parallel, so we can reduce the total build time down. So at a high level, how this works, you have a pool of workers, right? You can use them like an autoscaler in the cloud, or if you have physical hardware, this is a Google developer group. So I'm hoping everybody has some sort of cloud environment. So you just have an autoscaler and you basically just distribute your test to those nodes. They run there. All the feedback trickles back to your build. Your build sees that as a single output, so it aggregates all of the data. Everything is bundled up in a nice package, so it looks like a single build, right? So now your builds are no longer limited by the power of your laptop. Okay, and anything you collect in your build, coverage data, those things are also aggregated as well. So your build, it looks like a single build. Now, I've seen many shops do this, what we call a CI fan out. It's basically you take a complicated build, you artificially break it up into chunks, and then you run it across different nodes. So this example shows a Jenkins file. It's basically just splitting up a bunch of tests to run them in 3 different nodes. Now, this is 3 different builds. These are not connected back to each other. So this kind of distributes the work, which is good, but it doesn't aggregate the data. I have to go poke around in my CI system to see what the output is. The first step may have finished in 5 minutes. The next one may have finished in 15 minutes. The next one in 10 minutes. So it's not really well balanced. You have to manually deal with that. But the big problem is this only works for CI, right? So I have a lot of developers maybe on my team. I want them all to be productive as well. All right, so a quick recap, right? So caching is great, but you still need to run tests. Running your tests all in parallel on a single machine is still limited by that power of that machine. And CI fan out is great. It's a great sort of stopgap, but it's a bit clunky and it only works for CI. So Netflix was able to take an hour-long build and get it down to 5 minutes or just under 5 minutes with using caching and test distribution. So you can check out that. Again, I'll have a link to this at the end. And we can talk about this stuff more in the Q&A too. All right, so the last step is kind of the monitoring stage, right? Like I raised my hand. Who has applications in production that are not monitored? Well, hopefully your build and your tools are also being monitored, right? Something goes wrong, right? Even if you have the world's fastest build, that's great, but it's the nature of the beast. We have failures. Things happen. So maybe you update a dependency and that changes the timing of your application, and then your tests randomly fail. Whatever it is, things happen in your build. So we need some process. So in the Java world, we created this free tool called Build Scans. You can check it out, scans.gradle.com. It's a free tool you can use for Maven, Gradle build tool, and SBT right now. I think those are the 3 that we support. But it's free. You can check it out. You can share your builds with teammates, and it can help you troubleshoot them. It is a great free resource, but I'll have a link to this at the end. But regardless, if you're not watching your builds, right, problems are going to crop up. The builds are going to slow down, okay? So if I send you a pull request to your project and it adds 5 or 10 minutes to your build, hopefully you'll notice, right? You're like, what is Brian doing? Like, this thing is horrible. But that's not what's going to happen, right? What's going to happen is the whole team's going to work on issues, and it's going to be, 10 seconds slow down here, 30 seconds slow down here, and eventually we're going to get that 5 or 10 minute slowdown, right? It's just going to be over a period of time. And it's not malicious, right? It's just that's just what happens. So we need to be paying attention to these things. If we start seeing our build speed drop, then we can hopefully adjust whatever it is. All right, we also need to watch for trends, right? If you work in a new office, maybe your internet connection in that office sucks, right? Or just congested. Maybe you just need a bigger pipe. Whatever it is, you need some data to figure that out. Again, in the Java world, if you have kind of an artifact proxy like Nexus or Artifactory, maybe you need to configure one for that location, right? Again, if you have data and you can compare it against your other offices or your home employees, you can figure this out. We need data, right? So I love this quote, right? So you can observe a lot just by watching. Okay, so it's really hard to make an improvement to a system if you don't have data on it, right? I mean, think about how you come to your boss and you're like, I fixed that system. I think it's a lot faster now, right? He's going to say, how much? It's faster, right? That's not a conversation you want to have. You want to say, I made this thing 10% faster, or you want to bring the problem to somebody and say, I think we can make this thing 50% faster, right? Here's where we currently are. Here's where I think we can get, and then track your progress, right? You need data. So I love to ask this question too. Are you tracking local build and test times, right? So are you tracking them at all? Do you know how long your processes are, right? If you're not tracking them, that is probably the first thing you should do, is figure out how long your processes are, how long your builds are, and then go from there. Again, you can't You can't improve the situation if you don't have a baseline. And then do these things change, right? So if you work from home, are they longer? They work from longer, I don't know, when you're on the train, whatever it is, how much do they change throughout the day, right? You need some data to figure all that out. All right, so is this the question we should ask? Is the cycle fast enough, right? So I know a lot of projects that have 2-minute builds. They're like, my build is great. And sometimes they just turn off the test and that's how they get a 2-minute build. But sometimes they have a lot of microservices and they just have really fast builds because they have a lot of really fast builds. Now, this is still cool. We should definitely be shooting for kind of the sub 2-minute builds. But let's take for a minute. If I just stood here, right, for 2 minutes, how long would it take you to pull out your phone? Right? I mean, this is a virtual event, right? I mean, your phone is probably in your hand right now, and you're just scrolling through Reddit or something. I don't know. But it is not going to take you long before you get distracted. Maybe 20 seconds, right? So your builds really need to be as fast as they can possibly be. So that is the wrong question. We really need to be focusing on it as fast as possible, right? This is what we owe our developers. All right, so getting back to DPE, I'm kind of wrapping things up here. So we believe that DPE fosters joy. Most of the people we ask also agree with us. It makes their jobs more enjoyable. But it's also a way to eliminate failures before they get widespread. Okay. So here's a screenshot of a dashboard that this issue apparently affected 18 different users across 250 hosts. Obviously, a lot of those hosts were CI systems. But maybe there's something we can do about this, right? If this issue is affecting that many people, maybe we can do something. Maybe that thing is just training, right? Or maybe that thing is a code change. Whatever it is, we need data to figure that out, right? If I gave you an hour to go fix something in your build, what would have the most impact, right? Again, without data, we don't know. Okay, so I love talking about flaky test. It's one of my favorite things to talk about. I put the slide at the end so I wouldn't talk about it the whole time. Now I have, 2 minutes to talk about it. So do you have flaky test is a question I like to ask. And when I'm in person, nobody raises their hand, okay? But then I start explaining the situation. So a flaky test or a flaky build is a process that runs or a test that runs and then passes. And if I run it again, maybe it fails or vice versa, right? Without any code changes, the process is basically indeterminate state, right? I just keep hitting the run button until it turns green, right? And everybody raises their hands. Oh yeah, we have that, right? So what is the first thing you do when your CI build fails? Okay, do you rerun it or do you look at the log? Most people say, I just rerun it, right? And that's a huge problem in my book, okay? So I think the whole reason why we have tests and these automated processes is to give us confidence that we can ship our code, right? So flaky tests, flaky builds erode that confidence. So if the first thing you do is hit the rerun button, right? We're basically training yourself to think that it's okay to just rerun the test and not worry about stability in your build, right? So this is negative value here. Okay, so again, if you just click the rerun button, you don't have confidence in your build, and that's a really bad smell. Yeah, so crying. John says he starts crying again in the field position. I'm right there with you. Like, it's so frustrating. So yeah, so the answer is all of the above, right? Everybody does this. You're not alone. Everybody does this. I complain about it all the time, and I still do this, and I know better, right? It's something we all do, but we need to improve the situation. You need to have some way of tracking your flakiness, right? If it's a flaky build, flaky test, whatever it is, create a dashboard, a wiki page, Slack room. I worked at a company that just emailed all their developers, hey, this test is flaky. Don't worry about it today. We're working on it, okay? If you have CI queuing issues and the first thing your developers do is hit the rerun button, that is not going to make your queuing issues any better, right? You're just adding more work to the queue. So that's going to exacerbate that whole problem. So focusing on fixing that flakiness actually fixes this problem as well, okay? At Gradle, we have kind of two main developer teams. We have Gradle Build Tool, and we have our Dev Velocity engineering teams. So when they encounter flaky tests, obviously they try to fix them right away. But if they can't fix them during the kind of the release cycle they work on, they often quarantine them, and then we schedule these things called flaky test days. And the whole team gets together, and it's virtually in our case, and then they basically all work on a list of flaky tests, right? And this does two things. This stabilizes our code base, which is worth it all by itself, but it also trains our developers that flaky tests, flaky builds, this flakiness is not an acceptable behavior, right? It's not something we want to do. So it's a great benefit all around. All right, so DPE is becoming a standardized practice. I think being productive and happier is a perfect pairing in my book. So I have, so this QR code, again, links to my blog, and you can get these slides. There's a previous recording of this talk, which I'll update at least by Monday. As soon as I get a link, I don't know if it's on YouTube or whatever it is, I'll just update the link. But I also have a link to what we call the Build Speed Challenge. So if you want to win this swag box, it takes like 5 minutes, I think, to go through. You can take a Maven project, a sample Maven project that we give you, a Maven or a Gradle project. You add build caching to it, and then I think you send us a screenshot. It's all through email, and then we'll send you a swag box, right? It's usually a t-shirt, socks, and stickers, and some other stuff. Don't quote me on any of that. This is the picture, so I assume there's at least a t-shirt and socks. But anyway, those are the things. And again, this QR code will give you the link to all of the other things that I touched on throughout this talk. All right, so that's a little long-winded, but if anybody has any questions, we have time for questions, and then I'll be around afterwards in the kind of the networking section. And then here's my social information. If you don't want to ask questions here, you can reach out to me later and ask questions there as well. All right. So can I answer any questions?
Yeah, the chat is open. I'll read them out loud. There were a couple during the session that we left to the end. One was on the slide where we had over time, different things, agile, DevOps, and then DPE. And with those close together, does it look like DPE replaces DevOps, or do they live together somehow? What is the?
Yeah, I think all of these things live together, right? So just like agile, right? Now I know I'm actually a big fan of Scrum, but it is one of my favorite things to pick on, right? I think everybody does it wrong or pretends to do it right and then doing it wrong or whatever it is. We all love to pick on it, but agile is still a thing, right? And then DevOps didn't replace agile; it just kind of influences how we work. And then DPE, I think, will help influence how we work. So whatever your kind of build tool or tool process is, again, Docker, right? If you're building a lot of Docker containers, you want to make sure that you can take advantage of the Docker cache, right? So being able to watch and monitor that would be a DPE process, right? So reporting on cache hits, cache misses, that would be a great thing. You want to ideally see that number go up, potentially, or at least have some understand why it goes down, or if your builds take longer. It would be those types of things. So you can apply this to any tool, any process.
And then John Shelburne had a question as you're getting into like developer productivity section and developer speed. Like for your HR department, how would you quantify development speed? Is there a way to measure it, or how do you put it into HR?
Yeah, so that's a great question. This is something that we started talking about a lot around the office or virtual office, right? So there's a lot of these mechanisms that feed back into HR as well. So if you have a lot of turnover, right? Turnover is incredibly expensive, right? So if you know your developers are happier, they're going to be less likely to quit, right? A happy developer isn't one out there looking for work. If someone doubles their salary, that's a different story. But hopefully your jobs are your employees are well compensated. If they're not, your employees should be looking for work anyway. That's kind of a separate task. But if they're happier, they're more likely to stay. So that alone feeds back into kind of the HR mechanism. If they feel they're more productive, more satisfied, they're also more likely to stay, right? If in doing my job that I like to do, if I'm frustrated every 30 minutes, right? I'm not going to be happy, whether it's intentionally or unintentionally, right? But if I can be focused and do the work that I like to do, and I'm happier, I feel like I'm going to get more done. I'm more productive. I'm increasing the value for the company, but again, HR terms, I think there's like a turnover conversation to be had here specifically. There's probably some other softer things too, like a lot of HR questionnaires, want to know how happy you are. I don't know how many meetings you have, whatever it is. There's a lot of those things that can be tweaked, I think, to play into this as well, if you're measuring it.
Mm-hmm. Yeah. So in HR terms, I mean, not HR terms, but if you're seeing high turnover, it could be a lagging indicator of developer joy. Maybe there's not that much joy. So yeah, thanks for that.
Exactly.
On another question from Chris Chandler, this goes to more technical. So some people have CI/CD systems that use ephemeral runners like GitLab, and he's wondering how does that relate to the remote cache, and any recommendations on how to.
That is an excellent question. Yes. So if you have ephemeral runners, the local cache doesn't do you any good, right? Because it's basically blown away every time. So the remote cache in that case actually is the only one of those two that matter for like GitHub ephemeral runners. So hopefully that answers your question. But the remote cache in that case is more important than the local cache. So if all your CI is ephemeral and all of the local cache still speeds up developer builds, but the remote cache will speed up CI builds and local developer builds.
All right, looks like Doug is answering some questions from John, and if maybe we can get some more of it in the networking session. But if you still have more questions, please put them in. I do have a non-technical question that I ask all the presenters. It's kind of a career question. So thinking back, you have all the experience that you have now. If you could talk to somebody that's starting out in their tech career, or go back in time and talk to younger Brian, is there any kind of career tips that you would give, or motivation or suggestions that you think younger Brian would have found helpful?
Younger Brian it took a long time to realize when to say no and push back. So I think that's a skill all by itself that isn't taught or isn't suggested, or maybe younger folks get taken advantage of because they're willing and eager. I've talked to a lot of folks that don't feel they have enough time to test the code they work on adequately. Or, I know early in my career, I was working 60 plus hours a week. I had a new baby, a new house. Like, I was the most stressed I've ever been in my life. It was a horrible time. And really, if I knew how to say no and no, I can't get this done, or push back on deadlines, or whatever it is, there's a lot to unpack there. It's not just saying no, but the culture of not just working too, right? That would be one of the things that I wish I would have had. But related to testing, I still talk to people. We don't have time to write tests. Well, how do you know the code you worked on? Like, I'm not just going to give somebody random code, right? I have to push back on my manager. I don't need to get to 100% testing, but I need to be confident enough that the code that I'm handing over to somebody is working. So pushing back and saying no.
Let's
respectfully though. I don't.
Yeah, respectfully.
No.
Yeah.
Respectfully.
Yeah, you don't want to be the angry no. Setting the boundaries. Maybe you have to do some explaining why there's a no behind there. Being the proponent of, we're development professionals and this is how we need to do it, so that we don't just meet this deadline, but in 2 years or 5 years, when we're working on this, that we have a system that still runs and can be maintained. I don't know. It sounds like a good
as soon as the thing goes live, it falls over, right? You don't want to be that person.
Yeah, exactly. All right. So I think that's the last live question. Thank you, Brian, for joining us. Thank you, everybody who's joined. And if you're coming in from another GDG chapter, glad that you could join us as well. all of our virtual meetups for GDG Cloud Southlake are set up with the co-host option. So if you see any future sessions that look interesting to you, maybe co-host them for your area. Glad to have you. And Brian, again, thanks once again for joining us, and for Gradle and Develocity giving you the time to come here.
Yeah, well, thanks for having me. I appreciate everybody hanging out and chatting and asking all the questions, and hopefully we'll chat in a few minutes here after the break.